For more than 70 years, two names have dominated the skies with an iron grip that shows few signs of loosening: Boeing and Airbus. Their aircraft carry billions of passengers every year, set global standards for safety, efficiency, and performance, and fundamentally shape the economics of airlines across every inhabited continent. These two aerospace giants define the very parameters of modern commercial flight. But beneath the surface of this comfortable duopoly, the aviation landscape is shifting in ways that would have seemed impossible just 2 decades ago. New challengers, state-backed behemoths with virtually unlimited funding, revived legacy manufacturers drawing on Cold War-era expertise, and nimble regional firms exploiting market gaps, are attempting to break what has seemed like an unassailable stranglehold on commercial aviation. Some pursue high-tech leapfrogs, pushing the envelope of aerodynamics, propulsion systems, and advanced materials science. Others take a more pragmatic approach, focusing relentlessly on reliability, production speed, and domestic market dominance before considering international expansion. All of them face the same brutal reality that has claimed countless aerospace aspirants. Designing a great airplane is only half the battle. Certification from multiple international authorities, intricate global supply chains spanning dozens of countries, engine availability from a handful of monopolistic suppliers, comprehensive maintenance networks that can support aircraft anywhere in the world, and the hardest commodity of all to earn, airline trust. These factors decide who survives in this unforgiving industry. Today, we examine the principal challengers attempting to rewrite the rules of commercial aviation, who they are, what they've built, how their technology genuinely compares to the established players, and whether any of them could realistically displace Boeing and Airbus in the years and decades to come. Number 1. The obvious challenger, China's COMAC. China's commercial aviation ambitions represent the most visible, most financially backed, and most geopolitically significant attempt to break the Boeing-Airbus stranglehold. COMAC, the Commercial Aircraft Corporation of China, is far more than simply an airplane manufacturer. It is the carefully orchestrated nucleus of a state-directed aerospace ecosystem encompassing airframes, supply chains, certification authorities, maintenance facilities, pilot training centers, and export customers, all aligned through government policy and financial incentives. The COMAC C919 represents China's most mature attempt to crack the single-aisle market that generates the bulk of commercial aviation profits. This narrow-body aircraft is designed to compete directly with the Airbus A320neo family and the Boeing 737 MAX. On paper, the C919 follows conventional design: an aluminum alloy fuselage, 2 high-bypass turbofan engines, modern fly-by-wire avionics, and a cabin width similar to its Western competitors, allowing comfortable 6-abreast seating. The engines powering the C919 are CFM International LEAP-1 Z turbofans, the same engine family that powers the A320neo and 737 MAX, which immediately tells you something important. COMAC hasn't yet developed a competitive high-bypass turbofan. Much of the avionics, flight control systems, and other critical components are sourced from Western suppliers, including Honeywell and Collins Aerospace. This creates both an advantage, proven, reliable systems, and a vulnerability that became painfully evident during recent geopolitical tensions. Technically speaking, the C919 is genuinely credible. Similar passenger capacity ranging from 158 to 192 seats, comparable range of approximately 4,000 to 5,500 kilometers, and promises of improved fuel efficiency relative to older generation jets. The aircraft features a supercritical wing design that reduces drag, modern winglets for efficiency gains, and an advanced flight deck that pilots familiar with Airbus or Boeing can transition to with appropriate training. But here's the critical distinction. Designing an airplane that performs well in test flights is exponentially easier than delivering it at scale, on time, with consistent quality to customers worldwide. COMAC secured certification with China's Civil Aviation Administration first, a necessary domestic milestone. But for global sales, certification from EASA, the European Union Aviation Safety Agency, and the FAA, the Federal Aviation Administration, is absolutely mandatory. These aren't merely bureaucratic formalities. They represent exhaustive validation of every system, component, and operating procedure. Without these certifications, the C919 is largely confined to domestic Chinese operations and politically aligned markets in Southeast Asia, Africa, and Latin America. Manufacturing hundreds of narrow-body aircraft annually is an industrial feat that took decades to perfect. COMAC has announced ambitious production targets, but reality has consistently lagged projections. Political tensions between China and Western nations have introduced additional complications. Export controls on advanced technologies have even affected LEAP engine deliveries at times, highlighting how geopolitics can abruptly throttle an emerging manufacturer. This has accelerated Chinese efforts to develop indigenous alternatives, including the ACAE CJ1000A turbofan, though this program faces its own technical hurdles. Beyond narrow-body aircraft, Beijing's aerospace ambitions extend into the wide-body market. The proposed CR929 is envisioned as a long-range wide-body capable of competing with the Airbus A330neo, A350, and Boeing 787 Dreamliner. Early plans envisioned Sino-Russian collaboration, but the program has been slow to materialize and increasingly complex politically. Engine selection remains the single most critical technical risk. The wide-body market presents even steeper barriers. Airlines expect unimpeachable reliability for long over-water flights, and airline risk aversion is extreme when committing hundreds of millions per aircraft. Bottom line, COMAC's strategy is fundamentally pragmatic. Dominate domestically, first where government influence can guarantee orders, import critical components while building local capability, then expand internationally as conditions allow. Technically, the C919 is competitive enough for markets that don't demand FAA or EASA certification. But scaling production to Boeing and Airbus levels, securing international certifications, and building comprehensive global support networks are the true hurdles, made exponentially more difficult by deteriorating geopolitical relationships. Number 2, Russia's UAC and the MC-21 family. Russia presents another state-directed challenger with deep aerospace heritage dating to the Soviet era. The MC-21 represents Russia's most serious attempt to field a modern, fuel-efficient, single-aisle aircraft capable of replacing aging Soviet-era designs and attracting international customers. The MC-21-300 variant is positioned as a next-generation single-aisle aircraft competitive with the A320neo and 737 MAX. It features a notably wider fuselage than Soviet predecessors, allowing comfortable 3-3 seating. The aircraft incorporates a sophisticated supercritical wing design, advanced fly-by-wire controls, and modern avionics that finally bring Russian commercial aircraft into the digital age. Initially, the program secured Pratt & Whitney PW1400G geared turbofans, the same engines powering the A320neo family. However, Western sanctions imposed following Russia's 2022 military actions forced an abrupt pivot away from Western suppliers, compelling Russia to accelerate development of domestic alternatives, namely the Aviat-Vigatel PD-14 turbofan. The MC-21's airframe incorporates modern composite structures in key areas, with claims of 15 to 20% better fuel efficiency than the aircraft it's designed to replace. Like COMAC, Russia faces obstacles beyond engineering excellence. Western suppliers initially provided crucial avionics, flight control computers, materials, and critically, engines. Sanctions progressively tightened these supply lines, forcing domestic substitution efforts that inevitably slow certification and production. International acceptance remains severely limited, constraining export prospects to nations politically aligned with Moscow. The aircraft has received certification from Russia's Federal Air Transport Agency, but FAA and EASA certification remain distant prospects given current geopolitical realities. The MC-21's most realistic near-term market consists of domestic Russian airlines and politically aligned regions. Its genuine technical strengths, spacious cabin, modern aerodynamics, and competitive fuel efficiency make it appealing where Western certification isn't required. But the global narrow-body market remains overwhelmingly dominated by Boeing and Airbus, whose comprehensive aftermarket networks, massive production scale, and proven reliability create formidable barriers. Bottom line, Russia possesses the capability and talent to produce technically credible commercial aircraft. But engines remain a critical choke point. International certification and market acceptance are as much political and commercial as aerodynamic, and current geopolitical trends work strongly against Russian aerospace ambitions. Number 3. Embraer and the Brazilian niche strategy. Not all challengers are state-backed programs pursuing nationalist ambitions. Embraer, Brazil's aerospace champion, presents a fundamentally different model. Identify underserved market niches, develop technically excellent products for those niches, avoid direct competition with Boeing and Airbus in their core markets, and maximize profitability through focused execution. The Embraer E-Jet family, particularly the upgraded E2 series, including the E175-E2, E190-E2, and E195-E2, represents modern, fuel-efficient aircraft specifically designed for thin, long-haul routes, regional connectivity, and smaller airports where A320s and 737s are uneconomical. These aircraft typically seat 70 to 146 passengers, filling the gap between large regional turboprops and mainline narrow bodies. The E2 series features Pratt & Whitney geared turbofan engines that deliver remarkable fuel efficiency, advanced aerodynamics including fourth-generation wings, modern fly-by-wire controls, and avionics incorporating lessons from decades of aviation evolution. The aircraft are genuinely pleasant to operate and comfortable for passengers, with cabin widths allowing 2x2 seating, a significant comfort advantage over 3x3 configurations in larger narrow bodies. Strong recent orders from airlines globally demonstrate robust market demand for right-sized aircraft. Airlines increasingly recognize that flying smaller, more frequent aircraft on thin routes generates better load factors and passenger satisfaction than flying half-empty larger jets, and the E2 family excels in this mission. Embraer's strategy reveals sophisticated understanding of aerospace economics. Dominate specific market niches where its products offer clear advantages, avoiding suicidal head-on competition where scale economics favor incumbents. Embraer focuses on engineering excellence within chosen segments, cultivates close relationships with regional airlines and low-cost carriers, and leverages partnerships to maximize market penetration. The company has invested heavily in comprehensive customer support, pilot training facilities, and global parts distribution. Recognition that aircraft sales represent only the beginning of decades-long customer relationships. Bottom line, Embraer brilliantly demonstrates that a technically strong, strategically focused manufacturer can flourish without directly challenging the duopoly. The company generates solid profitability, maintains healthy order books, and earns industry respect. Moving upmarket would require massive capital investment and scale that Embraer currently lacks, risks that management sensibly chooses to avoid. Number 4. The A220 story, Bombardier's indirect victory. The fascinating story of the Bombardier C series, now known as the Airbus A220 family, perfectly illustrates how a challenger can succeed indirectly through strategic partnerships when direct competition proves financially unsustainable. Bombardier developed what many aviation experts considered a genuinely revolutionary small single-aisle aircraft featuring advanced aerodynamics, Pratt & Whitney geared turbofans, extensive use of composite materials, and excellent per-seat economics that threatened Boeing's 737 and Airbus's A320 in the 100 to 150 seat segment. The C Series, specifically the CS100 and CS300 variants, incorporated technology typically found only in larger aircraft. A clean sheet design optimized with modern computational fluid dynamics, an aluminum lithium fuselage that reduces weight while maintaining strength, a composite wing delivering exceptional aerodynamic efficiency, and geared turbofans that significantly reduced fuel burn and noise. Early customers praised the C Series enthusiastically. Pilots loved the handling characteristics and modern flight deck. Passengers appreciated the spacious cabin with large windows and lower noise levels. The aircraft genuinely delivered on its performance promises, achieving fuel burns 20% better than the aircraft it was designed to replace. But technical excellence alone couldn't overcome brutal commercial realities. Scaling the program globally required billions in development costs, sophisticated global supply chains, comprehensive support networks, and the financial staying power to survive the notorious valley of death that new aircraft programs face. Boeing, feeling genuinely threatened, leveraged political influence to impose massive tariffs on C-Series sales to U.S. airlines, potentially destroying the program's economics. Recognizing that Bombardier faced potential financial collapse despite having designed an excellent aircraft, Airbus made a strategic move that shocked the industry, acquiring the C-Series program for essentially nothing, gaining control of a modern aircraft design while Bombardier retained production capabilities in Canada. This partnership transformed everything overnight. The aircraft was rebranded as the Airbus A2 2100 and A220-300, immediately gaining access to Airbus's massive global sales network, established customer relationships, comprehensive support infrastructure, and political influence. Today, the A220 competes effectively against the Boeing 737-700, 737-800, and smaller A320neo variants, filling a market segment that Airbus previously struggled to serve profitably. Airlines that might have hesitated to bet on Bombardier happily order from Airbus, demonstrating how brand strength and support networks matter as much as technical performance. Bottom line, technology alone isn't sufficient in commercial aviation. The C-Series, a 220 story, proves that global sales infrastructure, comprehensive aftermarket support, and established airline relationships determine success as much as aerodynamics and fuel burn. The aircraft succeeded because Bombardier wisely recognized when partnership was necessary for survival. So who's closest to breaking through? Objectively assessing each challenger's prospects. COMAC is closest in terms of scale, financial backing, and market size. It possesses government support that can guarantee domestic success regardless of commercial logic. Technical capabilities are steadily improving. Primary obstacles: international certification, supply chain reliability, geopolitical tensions, and building global support networks. The timeline for genuine global competitiveness is 10 to 20 years minimum. UAC MC-21 is technically credible with deep aerospace heritage. Realistic prospects are severely limited by geopolitical isolation, engine development challenges, and international certification barriers. Best-case scenario involves regional success within politically aligned markets. Global competitiveness appears unlikely under current circumstances. Embraer is already successful within chosen niches, proving that smart strategic positioning beats direct competition. Unlikely to challenge Boeing and Airbus directly, but doesn't need to for profitability and longevity. Represents the most sustainable challenger model. Future startups and smaller manufacturers can carve profitable niches in underserved segments or develop innovative technologies that attract acquisition by major players. Direct competition with Boeing and Airbus remains unrealistic for smaller players lacking massive capital and political backing. Breaking the duopoly ultimately requires simultaneously overcoming multiple formidable obstacles. Engine technology. Modern high-bypass turbofans represent multi-billion-dollar, multi-decade development programs. Only a handful of companies globally possess this capability, and all face export controls on advanced technologies. Certification complexity. Airlines won't adopt unproven aircraft without exhaustive regulatory validation from multiple international authorities. This process requires years, costs hundreds of millions, and demands complete design transparency. Aftermarket infrastructure, parts availability, field support, maintenance training, and technical assistance must span the globe. Building these networks requires decades and massive ongoing investment. Airline trust. Perhaps the single hardest commodity to earn. Airlines stake their businesses on aircraft reliability and support. New manufacturers face extreme skepticism until proven over millions of flight hours. Political and trade dynamics. Export controls, sanctions, tariffs, and geopolitical tensions can instantly undermine commercial prospects regardless of technical merit. Two plausible scenarios emerge for the next 20 years. Scenario A. Boeing and Airbus continue dominating large, single-aisle, and wide-body markets through scale advantages, established networks, and airline inertia, while challengers like COMAC, UAC, and Embraer carve out regional niches and politically influenced markets. The duopoly persists, but faces selective competition in specific segments. Scenario B. A challenger successfully masters genuinely revolutionary propulsion technology, cultivates unbreakable political and commercial partnerships, or exploits Boeing and Airbus stumbles to capture meaningful market share. This scenario remains possible but faces long odds. Either way, the duopoly isn't invincible forever. But dislodging Boeing and Airbus requires solving complex engineering challenges, commercial obstacles, and political complications simultaneously. A feat that explains why so few have succeeded. Designing an airplane is an act of engineering courage, demanding years of intense effort from thousands of talented people. Building a global aviation brand capable of sustaining competition over decades is an act of strategic patience, requiring financial staying power, political support, market timing, and sometimes plain luck. The challengers, COMAC, UAC, Embraer, and future contenders demonstrate both tremendous promise and sobering peril. Over the next decade, expect commercial aerospace to evolve toward a more multipolar landscape, with multiple players competing effectively in their respective niches, even as Boeing and Airbus retain dominance in core markets. This evolution benefits airlines through increased competition and benefits passengers through innovation and choice. When you next step onto a commercial flight, look beyond the paint scheme and airline branding. The jet beneath your feet represents the culmination of thousands of engineers, certification specialists, supply chain managers, regulators, and strategists, all competing in perhaps the most challenging manufacturing endeavor humanity has undertaken. The story of who builds your next aircraft is ultimately a story about innovation, ambition, geopolitics, and the relentless difficulty of making impossibly complex machines that safely carry millions of people across the sky every single day.